Hi everyone, today let's solve the 2024 AMC 12A problem 19. And the problem reads, cyclic quadrilateral ABCD has lengths BC is equal to CD is equal to 3 and DA is equal to 5 with angles CDA equal to 120 degrees. What is the length of the shorter diagonal of ABCD? Now, to get started, let's draw a diagram. So, since it's cyclic, it can be described in a circle. And let BC equals CD, all of these are 3, and DA is equal to 5. And to finish the quadrilateral, we draw a line. And angle CDA is equal to 120 degrees. So we know that here it will be 120 degrees. And let's draw this diagonal here, CA. Now we want to find the length of the shorter diagonal. So let's draw both diagonals. And we know that we can find CA because we can find that using the law of cosines on triangle CDA. So we know that CA squared will be equal to 3 squared plus 5 squared minus 2 times 3 times 5 times cosine of 120 degrees. Now, we can find cosine of 120 degrees really easily, right? Because it's just negative 1/2. So since this is negative 1/2, we can just plug it in. CA squared is equal to 9 plus 25 plus 15, and that just give us CA is equal to root 49, which is equal to 7. So CA will be equal to 7. Let's just make it green. Equals 7. Okay, and now let's find the length of AB, because in that we can find the length of BD if we know AB with Ptolemy's theorem. And also in a cyclic quadrilateral, remember that this angle plus this angle will be equal to 180 degrees, because that's the property of a cyclic quadrilateral. So since this is 120 degrees, then we know that this must be 60 degrees. And let's call the length AB equal to A. Then we can use the law of cosines again, since we already know that CA will be equal to 7. So we know that 7 squared will be equal to 3 squared plus A squared minus 2 A times 3 times cosine of 60 degrees. But cosine of 60 degrees is just 1/2. So we know that just be subtract 3A, 9 plus A squared will be equal to 49. And 0 will be equal to A squared minus 3A minus 40. And this factors as A minus 8 times A plus 5. So we know that A must be equal to 8 since A cannot be negative. So instead of A, we can just erase that and put 8 instead. 8 instead. 8. Okay. And now, since we know all of these lengths, we can use Ptolemy's theorem. Basically, what Ptolemy's theorem says is in a cyclic quadrilateral, if we let this be A, so this length here times this length here plus this length here times this length here will be equal to the product of the lengths of the diagonals here. We can prove this using trigonometry, but I won't be doing that here. Just remember that it's a true result. So we can now apply that up here, and that gives us, since we only don't know BD, we know all the other lengths. We know that this length times this length plus this length times this length will be equal to this length times this length. So let's compute that. It gives us 3 times 5 plus 3 times 8 will be equal to, since we have a 7 here, 7 times BD. And this gives us 39 is equal to 7 times BD, so BD will be equal to 39 over 7. Now, the length of our two diagonals are 39 over 7, and since we already found that 7, we want to find the length of the shorter one, and that's 39 over 7, so the answer will be 39 over 7, which is answer choice D. Thank you so much for watching. If you learned something and enjoyed it, please consider supporting me by liking and subscribing. See you next time.